Here you go.
This,
We're recording now.
okay, this is the email I sent out to many people in ProRate Energy and Geoengineering articles, and also the GNICC. So what I want to do is give an overview and then get into the meaty stuff. So an organization called Reflective, actually, it's a nonprofit, and this is their domain, reflective.org, um, was created in response to an article that was published by a esteemed group of scientists, led by scientists at Columbia University, and they come up make a lot of assertions, which I sort of um, super are sort of summarized in the second email I'll talk about, because this email I sent to our list in end of March because it was talking about a presentation by Volts. Dave Roberts does these um, audio events, not video, and his title of it was "Should We Block Some Sunlight to Cool the Planet?" And it's quite a long article. It's worth listening to, and I pulled some highlights out of it, out of the article, and that is the scientists that again reflective is based on believe that they're going to put pollution in the atmosphere, SO2, and it's going to cause some death. But the ratio of good to bad, namely how many deaths you avoid to how many deaths you create, is around 100 to 1. And I don't really know that number, but that's the kind of numbers that were talked about roughly when when Dave Roberts interviewed Dakota Gruner um, in his hour-long audio. And these are the kind of things I
I,
pulled out of it.
I have a quick question about that 100 to 1 stat. Was that
Yeah,
taking into account the totality of the implementation or just in the short term?
that isn't
If there were
that
any trade-offs from short to long term.
was very very vague. It was not. We didn't go into it and find out what you really mean by that.
Yeah.
All it is to say is they believe that there's a lot of bad going on, and this probably has a added about a bad because you're injecting SO2, which will turn to H2SO4 and make acid rain. And if you do that, that's not good for most life. And therefore, there is bad. The question is the good outweigh the bad enough to do it? And the scientists, I'm referring to this article here. The scientists are, yes, it is. In fact, they got hundreds of climate scientists and others to sign on to this article to say yes, it's worth the risk. But they actually do believe there's a risk, namely, there people will die. Okay, so and part of their science was that they looked at the fact that volcanoes have dosed the planet with SO2 for a long time, probably as long as the planet's been around, 4 billion years. And life's gotten on with it, gotten used to it, respond to it. And therefore, we're not doing something completely out of whack. But they're not talking about putting a lot. They're saying the SO2 that's already in the troposphere, which is the atmosphere, lower layer that we live in, is 80 million tons. And they want to add some to it. And the question is it 20 million, 10 million, 10,000? And that's going to be part of what's unclear in this talk. But that's okay. They want to put some SO2 in the atmosphere, and they claim when you do that, you will cool the planet. In fact, they say it only take 20 million added tons of SO2, and that'll cool the planet to what it was in around 1950. I'm 80 years old, so
So correct
around.
me if I'm wrong. The argument is that jets are more efficient in the stratosphere above the troposphere,
No, no, no,
and
no, no, no.
and
Wait,
then
wait,
we
wait,
can have higher sulfur in the fuels.
no, just a minute.
Yeah.
What, you're jumping ahead. The
Yeah. Yeah.
question of how to get it in the atmosphere isn't really discussed in this
Oh,
group of.
okay. 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 I thought that's where it was proposed.
You know. However, if you go to their website, reflective.org, and we can go there really quick by clicking on it, and I'll go to that place here. If you go to that web page, you'll see they have a research section where they allow you to look at their uh, uncertainty database, and they also have a tool, which I forgot what it is. Yeah, one of the tools is a SAI simulator. What's SAI? That's stratospheric aerosol injection. So you can click on it, and the reason why I'm doing it is because this answers one of the key questions related to what um, Brendan just said. Okay, so just let me explore. We're just going to skip all this stuff. They're giving it apology because they don't really know it works and so forth. But anyway, here is a slider that says if you don't use SAI, you get what's on the left, and if you do use SAI, you get what's on the right. However, doing what? Somebody want to jump in and ask a question? I'm not
Also,
sure.
welcome Dr. Saeed to the meeting. Just letting you know, Mike.
Hello, Dr. Said. So, okay,
Hello.
so they think that there are balanced good and bad, and if you try to get the planet to the 1950, try to go to here. Okay, if you did that, what would you have to add to the atmosphere? And they actually addressed it in this slider. So if you decide I want to get to 1950, then let's see, I want to get it. How much do you want to decrease it? So I want to decrease it um, to 5 degrees warmer than it was when they started, and warmer than it was when we started. Remember, this is a graph. So 1900 is about what it was. Okay. In 1950, it got bigger. Over here, there is a half a degree more. If you look in the graph, what I'm pointing out, the little thing that popped up, that's a half degree warmer than it was in 1900. Okay. So if you want to decrease the temperature to 1950, then this is how you would say, I want to decrease it to one half a degree centigrade above. You say, okay, I want to do that. And what happens? So it says you need to put in 50 planes into the atmosphere by 2021. I says 500, I'm sorry, 505. I'm just saying 500 to round up. Each one of these flights is 20 tons, okay? And 10 flights a day, year round. And by 50 years from now, actually 75 years from now, you will have put two, the kind of tons I say, it's 20 million tons in the atmosphere. But in fact, in any one year, 20 times 500 is 10,000 tons. So if you put 10,000 tons a year for a half a century, you will reach this goal. Okay. And then you look at what you've done. You've set it to this minus, and you'll see this is the current climate on the left, and this is the desired climate on the right. Okay. Okay. And so this is sort of the starting point of the discussion. If you decide to immediately add enough SO2 to the atmosphere, and the stratosphere, in fact, you can get the temperature down to what it was in 1950, and it'll stay there as long as you keep injecting all the way to 2021. That's their assumption. It's based on a lot of science, and based on that science, this simulator calculates based on the science of the article published by the Columbia University scientists. In fact, a couple of those scientists are on the nonprofit team. However, as good as that is, it's not super 100% unequivocally good. Why? Because you added SO2 to the atmosphere, and SO2 makes acid rain and so forth. And therefore, we wonder, is it worth it? And these scientists decided, they voted as if they had a right to vote. They voted. They said the damage that you do nothing is so much worse than whatever it is you're doing that they're proposing, and that's why reflective came into existence. So I'm going to pause a minute to find out if anyone has a question about that, because that's a hypothesis central to this discussion. Anybody have a question about that?
Yes, Myron, this what is the website you're using here? What is the website?
Reflective.org. They have a simulator.
Oh,
Yeah.
Oh, look, see right here, reflective.org. See that?
yeah. Okay. Okay.
Okay.
Um,
And I also said that if you look at the email they were looking at, which is the one that started this whole conversation, I make reference to, it's over here. This email, we say, okay, we're talking about this website. Okay.
oh,
So this
The
nonprofit
nonprofit. Yeah.
came into existence in the last few months in response to the article that was published by these scientists some years earlier. Okay. In fact, some of those scientists have joined the nonprofit to help steer it and help create that page that we just saw, their SAI simulator. Okay. Now, we're starting from this. But one of the things I want to point out is they say we are going to decide to do it now, but notice now isn't 2025 or 2026. Okay, it's 2035. You don't actually start injecting SO2 in the atmosphere for an entire decade. That's their model. Why? Because they don't think they have the airplanes to do it, and they don't feel comfortable about doing it quickly because there are too many things that could happen that they don't know about. And I think they have the wrong assumption. And that's because the amount of bad is really bad. And I don't think we can wait uh, 10 years. And as Tor would quickly point out, we will probably lose most of the important ice on Antarctica, and sea level will rise. New Orleans won't exist, and a whole bunch of other places won't exist. That's a lot of damage. And of course, the people who are dying from the heat waves, et cetera, et cetera. I don't think it's appropriate to wait, especially if we can do it. And that's the whole point is, can we do it? And can we do it without causing harm? So again, I want to remind you, this discussion has this key sentence. Can we rapid reverse climate change with no environmental harm? I emphasize the word no because unlike the scientists in Colombia, they expect to generate environmental harm. And I'm going to show you a pathway to do this faster, cheaper, with no added environmental harm. And that's what we're going to go through now. But again, I want to ask everybody if they understand what we're doing and talking about. Okay, so this is an email I sent to the same group of recipients um, last week on July 14th. And it is a revision of an email I sent earlier, and its subject is slightly similar to what we're talking about. A outline of a geoengineering article, which I hope to write. Maybe the people in this particular meeting will be co-authors of that, and we will come up to this thesis. And part of what we're doing tonight is examining the thesis and the weak points in the thesis.
Sure.
So, so that's why we're having the meeting to go through it. So, all right. So let's see how I argue. So first of all, I want to clear the air as to what the assertion is. So I'm going to change the screen resolution a little bit to make it bigger so it's easier to read. And what am I saying? I say a negative cost without creating any new technology, building new vehicles, or adding more pollutants. Remember, reflective.org needs new airplanes, and we don't have them now. Okay. And whatever they cost, that's an extra cost. And they don't want to do it now. They want to do it a decade from now. Okay. Then and I say without adding any more pollutants than we're already doing. I'm not saying we're not going to cause environmental harm, but we're not going to cause more harm than what we're already doing. That's not a nuance. And you'll see why a lot of environmental harm is already going on and related to this subject. And we have to be careful what we're doing because if we decide to stop doing one thing, there'll be a side effect that can cause more harm. All right, we'll talk about that shortly. So, my proposed treatment, the treatment, which is described in this sentence, we'll go through in a minute, can expect to lower Earth temperature by 1 and 1.5 degrees centigrade within a few years. That's exactly consistent with what Reflective said. I just showed you in their SAI simulator. And if done as soon as possible, can completely avoid the warming expected during the impending El Nino, which, in case you haven't checked, they predict 2 tenths of a degree warming for the whole planet. This is a lot more cooling than that warming, but it'll decrease acid rain where it's most, and not, I don't mean delirious, I mean deleterious. I misspelled it. Nobody pointed that out. And provide a proof of concept to a set of solutions already on the drawing board but reflective, but otherwise planned to be implemented a decade earlier than the nonprofit is willing to promote. Okay, that's my thesis, and I'm now going to explain it. Again, anytime you have a question, please jump in. It's going to be 18 assertions, and we'll go through them as fast as you need to get them done in a half an hour. But that I'm still leaving room for
If it's
questions.
okay, Myron, I'll share my screen and I can zoom in a little better on the yeah.
Okay. Well, anyway, you want to change your sharing?
Well, I noticed you're kind of zoomed out and not on the you're sharing the screen rather than the
You
application.
want me to
So
stop
if it's
sharing?
okay, I'll just do this.
I'll let you share instead of me,
Sure. Yeah,
and
so
that
this
way.
way it'll just be a little more legible.
Okay, but
Recording in
this version,
progress.
are you using the version that I sent to you with the added stuff in red? Or the ones? Are you looking at version 1 or version 2?
Not sure. We can perhaps find out.
Oh, all you have to do is look at the first thing in red, and the first thing in
Well,
red.
I did stuff in on non-formatted.
Or just look. Let's look at this first assertion.
Yeah,
I'll read the first assertion as it is on this mine, and you tell me if it's the same thing. Go higher on your screen.
I'm on the first assertion.
No, that's the no above that, above,
The
above,
thesis. Oh, the
right,
beginning assertion. Okay.
right there. That assertion.
Well, it's not really an assertion, but yeah, it's an
Okay.
outline.
All right. So now the word. Read the word thesis. At negative cost without creating new challenges, building new vehicles, or adding any more pollutants. Okay. Does it say adding any more pollutants?
Or adding any pollutants to our atmosphere.
Adding any more pollutants, okay, than we're already doing. Does it say that we're already doing? No, it's not the same version. So I appreciate your
Oh,
recommendation.
all right.
But
Well, yeah. I mean, you could share if you have a more recent version.
let me do my
It's
share.
just it's in the center of the screen, and if you could share the whole thing and zoom in so that it's yeah. Go ahead, Tor.
All right, I'll try to zoom in better. Okay.
To go in at a base level and point out the assumptions are entirely from the atmospheric school of climate change.
Oh, absolutely right.
They
And Tor is
are,
absolutely, and so I'm talking about the atmosphere. Tor is absolutely right. This is an
yes.
atmospheric perception of the problem, and the problem's way bigger than that. Tor pointed out that the extra heat in the ocean dwarfs the extra heat in the air. But let's just do the air, which is already a lot
No,
to
no,
do.
no, no. I want to point out. Um, I mean, I just popped up the airnow.gov site, and it's
Can't
fired
take
all
one
over
time,
Canada.
Tor. You
Uh,
can't talk one time talking because I'm going to get through all at points, and I don't want you to slow me down. So I'll give you
okay,
a
okay. I'm gonna say, yeah.
okay. But anyway, no, this is the stuff I'm talking about. I already have somewhat reduced the clutter on my screen. So anyway, we're not going to add more pollutants than we're already doing. It's key point. The pollutions that are already put up there, we're not going to add to it. So therefore, there's no extra harm by using this treatment. And the treatment is using whatever mechanism we can, whether it's an international injunction, an order, agreements with 90% of airlines, but require about 1% of those passenger jets that are flying mostly in the troposphere to instead fly mostly in the stratosphere. That's a very tiny change in what we're doing, and that will in fact lower the damage to the biosphere, which I'm going to explain. So therefore, we're not adding more pollution. We're just changing where the pollution is injected into the atmosphere. It's a key point. Now let's go look at the various facts that justify the conclusions I said earlier. First of all, SO2 reacts in the atmosphere to form aerosols of SO3 and eventually H2SO4 to make acid rain. Nobody disputes this. Okay, I'm sure we can find lots of things. Now, it's also interesting that no matter where the SO2 is injected, where the troposphere or the stratosphere, the same thing happens. Okay, acid rain is generally harmless to animals, but repeated or persistent acid rain can kill trees, degrade limestone facades, etc. So although you aren't personally, according to the data I've seen, maybe someone knows better, acid rain doesn't hurt people, it hurts plants, and indirectly it hurts people. So, Brendan, are you taking over for me again?
Yeah, this is the updated one. Yep.
All right. Well, anyway,
What?
if you want to do that, some of them are going to be a little different. When they get to be different, I'll let you know.
When are
So
they
I'll-
different? Because this is the updated one with red.
Okay. All right. Oh, we've got some more people. We have Debbie
Yeah,
Riddle
welcome, Debbie.
has joined us. Debbie lives in San Diego. I met her in Hawaii a few weeks ago, and she showed me her condo in Hawaii. But that's getting us off the subject. So, okay. So now I'm looking at the numbered steps needed to reach this. So the third step is that 1 gram of SO2 reflects incoming solar energy, as well as 1 ton of carbon dioxide retains infrared heat, which means that as you add SO2 in tiny quantities, you displace the effect of carbon dioxide in grand quantities. And that's why.
Mommy says I just got home.
Hello, Debbie. Are you talking?
Yes. Oh, sorry. I didn't realize. I thought I was mute. Hold on. Let me take the
It's okay.
audio.
All right. Okay. You are welcome to talk if you want to. This is not supposed to be Myron talking at you. If you want to ask a question, please feel good to do that.
Or showing some fingernails.
All right. So we learned this because of the Mount Pinatubo earthquake of 1991. And they said that 20 million tons of SO2 was placed in the stratosphere because of that, and it cooled the planet by 0.5 degree centigrade within a year. It stayed that way for about a year and a half. So we know it works. Question is, how can we make it work when we want to? So there's a problem though. SO2 is a much longer half-life in the atmosphere. I'm sorry, CO2 has a much longer half-life than SO2, where CO2's half-life is about a century, and SO2 has a half-life much shorter. It's about a year in the stratosphere and less than a month if it's placed in the troposphere, which means that if you're going to put it in there anyway, why not get more out of it by putting it in the stratosphere? It'll be in the atmosphere 10 times longer, roughly, if you put it in the stratosphere than the atmosphere, but not cause any more harm by being there. Therefore, SO2 in the stratosphere must be renewed for at least a half a century to create an effective long-term counterbalance to SO2's induced warming. As we looked at before, in the reflective.org approach, they want to do it from 2035 all the way to 2021. That's like 2/3 of a century. And that's their perspective. So anyway, so SO2 placed in the stratosphere is a very interesting statistic, and you can look it up. There is a certain wind has been observed by a certain scientist, and therefore it's called his wind. Anyway, so SO2 placed in the stratosphere is typically windborne to the winter pole. So if we put it in the stratosphere right now, it would go to the Antarctica. But if we did it in the relative our winter or our late spring or early spring or late autumn, it would go to the Atlantic pole. I mean the Arctic pole, which of course is in the vicinity of Canada. As I pointed out earlier, Canada has a lot to be interested in this technology because they are getting their forests burnt out now. And so it's probable that if you put atmospheric, stratospheric SO2 then it's going to go to the winter pole and fall on the forests of Canada. Okay, so now I'm reading the next one. So SO2 placed in the stratosphere is much, much likely to harm the biosphere and the same amount placed in the troposphere. Okay, if you should be following this. Okay, so the bottom of the stratosphere is called the tropopause. It's the top of the troposphere, so it's called the tropopause. It has varying heights where it is thousands of feet lower at higher latitudes, like say 45th latitude, which might be like near San Francisco or state of Washington. The 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 bottom of the stratosphere or top of the troposphere is maybe 20,000 feet, whereas if you're at the equator, it's more like 40,000 feet. But nevertheless, our commercial jets can fly into the stratosphere almost anywhere they are in the planet. Now, so that says we could get the SO2 injected into the planet with our passenger flights. And turns out jet traffic is more efficient and faster in the stratosphere than the troposphere. So if we ask an airline company to move their jet flights from the troposphere to the stratosphere, they're not likely to push back too much because the plane flies more efficiently, even though it does have it travel slightly further if it travels up and down, not just parallel to the surface of the Earth. But nevertheless, it's probably not a burden for the airline to go more stratospheric than tropospheric. Now, in the troposphere, the top of the troposphere is where we have cirrus clouds. And cirrus clouds is the only cloud that reflects more infrared energy down than it reflects solar energy away. And that's why people rail against jet traffic in the troposphere, because it creates jet trail induced cirrus clouds, which are also called contrails. So these contrails are inadvertent negative effects of airplane travel. And so if we get airplanes not flying in the troposphere and instead flying in the stratosphere, we get fewer or less of these contrails, and we have less negative effect on our planet, or a positive effect of increasing climate change. So we're better off having planes not fly in the troposphere as much as possible. Now, here's something very interesting. Sulfur is already in jet fuel. I was actually told about this by a colleague who happens to have a chemical engineering degree, and he said you could add more sulfur to jet fuel and it wouldn't hurt the engine. In fact, when I started studying this, I found out that it's already in jet fuel. To decrease the adverse environmental effects of the sulfur in jet fuel is refined to make it lower in sulfur. However, you can't make it too sulfur free, because if you do, the jets can't use the fuel because it messes up their ability to deliver fuel in the airplanes through the system seals and valves. So you can't reduce sulfur below some percentage because the planes can't fly. So you make it as sulfur free as possible, and that costs more. I don't know how much more, whether it's 10% more or 200% more, but more sulfur free is more expensive jet fuel. So again, if we were telling the airplane, go ahead and use more sulfur and put more sulfur in the atmosphere, it probably wouldn't deleteriously affect the airline industry's bottom line.
So it sounds like
However,
there's a two-pronged approach. One is the location where the fuels, where the trails are happening, right? And then the second is whether we want to change the fuel mix,
right. So I'm not encouraging the industry to change the fuel mix, but I'm just pointing out, if they change the fuel mix to have more sulfur in the fuel, they will increase the amount of sulfur injected to the atmosphere without challenging their economics. However, they will put more sulfur in the atmosphere, and that will cause more harm. So even though I make this point number 9, I'm not using it as part of a mechanism, because we're not going to be changing the sulfur content in the fuel. I'm just pointing out the sulfur is already in the fuel, and you can't decrease the amount of sulfur in the fuel beyond a certain point because the airplanes won't be able to control the fuel. So they're already as sulfur free as possible. So I picked this statistic up from AI. I asked how much sulfur dioxide is placed in the atmosphere by commercial jet traffic worldwide, and the answer is 2.6 million tons. And you might look at that number as very significantly close to what reflective wants to do. They want to put 20 million tons over 70 years. And if you divide one by the other, that's like 10,000 tons a year. And 10,000 tons a year is about 1% of that number. And that's all we're talking about adding. So SO2 is already, I've already said this, when it's placed in the stratosphere, it tends to go to the winter pole. So 11 is redundant with number 4. And then number 12, 40% of the time commercial jets travel in the stratosphere. So this is the US exposure of commercial jet traffic. Worldwide, I couldn't find a statistic, but I found this statistic. And if we assume it extrapolates to the rest of the planet, that would mean of this 2.6 million tons, at least 1.3 million of that is tropospheric flight. And that's the kind of flight I'd like to redirect. So if we take the data in number 10 and 12 above, more than 50% of the 2.6 million tons of SO2 are already being injected in the troposphere by passenger jets, namely 1.3 million tons, is rapidly polluting the biosphere because it doesn't have a long half-life. It falls out quickly and makes acid rain, and doesn't stay aloft long enough to cool the planet. So if we get 1% of these flights, that's 13,000 more tons into the stratosphere, which is 1.3 times as much as the scientists at reflective.org say we need to cool the planet to what it was in 1950. I don't know if you're following all I'm saying. All this is what I've been talking about. Namely, we could cool the planet just by getting 1% of the flights in the troposphere to fly in the stratosphere. That's exactly what Reflective says. That's what their scientists say. And we don't have to add more sulfur to the biosphere because it's already coming out of our passenger jets. The passenger jet is polluting our planet. Big surprise. Nobody is surprised by the pollution caused by industries that don't care what they do. However, in this case, if we just make a small change in what they do, we can cool the planet. So they say that to get the 10,000 tons a year, which is the same as 500 flights at 20 tons a year. You might remember, we looked at this before. I'm going to jump back to that page. We looked at this earlier for those who walked in late, okay? This says we're going to put, I want you to look at the screen, estimated airplane fleet for SO2 deployment in 2010 assumes each plane has 20 tons of SO2 a flight, and it's 500 flights a year. If you multiply 500 times 20, that's 10,000 tons a year, which is the same thing I just said over here. Okay, so 10,000 tons a year, and that is less than you get if you just get the tropospheric flights to go into the stratosphere. Remember, only 1% of them. Okay, and we would get the planet down to what it was in 1950. So SAR, remember, that means stratospheric aerosol. This should be an I, not an R. Done like reflective is researching, would concentrate more than 90% of the acid rain at the North and South Pole, which will greatly reduce the biospheric harm per gram of SO2 injected. Okay, number 50. Since the benefits of stratospheric aerosol injection, I'm sorry about the R there. When I went to high school, my fraternity was SAR. So I started typing SAR, but that should be SAI. Okay, because remember, it's the SAI simulator. Okay, the benefits are linear with the amount of injected. So therefore, if you do 1.3 times as much SO2 injection, you'll decrease the temperature by 1.3 to 1.8 degrees, namely to the temperature of 1900. Now that's good, but as Tor points out, and he's anxious to say, and I'll give him a chance to repeat it, we're just cooling the atmosphere. We're not cooling the whole planet. And there's a lot of heat in the ocean that we won't cool off this fast. And that's something we should think about. Maybe we should be shooting for cooling it down 6 degrees centigrade to cool the planet enough to cool the oceans. But that's another conversation. I'm not going there right now. So reflective scientists believe that even increasing SO2 pollution, even if you had to increase SO2 pollution, this is going back to the original article published by Columbia University colleagues. They say they believe that doing that causes so much more good than harm, it's worth the global harm because it is more benefit than harm. In fact, I compare it to the ethical argument of going to war. Namely, if you go to war, if you have a country that's choosing to go to war because some country attacked you, you'd say, well, if I kill them, well, they won't kill me, and my people are worth more than your people. Or they could say, maybe I'll kill one of them and I'll save 100 of myself. And that's the kind of ethical argument one uses for going to war. And that was, I believe, is the argument they used for their original argument to create reflective.org in their science. And then a war can be justified. However, the treatment that I'm recommending does not increase SO2 pollution at all, not even a little. It only changes where the direct deposition to the environment occurs, from 60% to 59% in the troposphere, and from 40% in the stratosphere to 41%, namely a 1% change. And because this method would utilize the stratospheric winds, push out pollution mostly away from the biospheric harm is decreased even if no cooling occurs. So I have two more points. A reasonable estimate of how much cooling is you're going to get by this. You take the SO2 injected and you compare that, it's less than 1 million tons a year to almost 1 million tons a year. So the amount of stratospheric pollution goes up by a small amount, and expected cooling is 1.3 or 130% of what Reflective's prescription is to drop the temperature to 1.5 degrees, namely to the 1950. Basically, you'll drop it to 1.8, which is getting to the year, dropping it to what it was in 1900. So we really will cool the planet, and we really will do it really fast, and we really will do it without adding SO2 to the environment. And then, because this particular email talked about the El Nino is predicted to raise the temperature by not by 0.5 degrees, but 0.05 degrees. And so it's way more cooling than the heating predicted by El Nino. So I want to pause again. I'm hoping someone will have a question. What is it am I saying? Why is this coherent? What am I guessing wrong? And Tor's going to say, well, you're only cooling the atmosphere. We're going to get to that. But if somebody want to talk about another aspect of this, did you want to say something, Debbie or Dr. Saeed or Brendan? Just jump in, turn off mute, and say something. So Brendan's giving us a lot of pictures, which helps us understand.
Yeah, I think visual always does better than just text or splicing in both. So one thing I like is, the approach of what are we already doing? Can we do something slightly different? It seems really simple. I guess the only drawback for airlines would be, if part of the cost is on the time of the flight or something like that, to persuade them to do something more efficient but less effective for commercial air travel is
Well,
probably a
I have thought about how do you induce it. In fact, we have a colleague in our board of ProRate Energy who believes this won't work because the airline industry will never reroute their planes. You can't get them to because they've already been working on their planes. And think about it, like Delta Airlines or Southwest Airlines or whatever, it's been around for decades, and they've already been battling of how to increase their bottom line. And they have time of use pricing so that the later you buy the ticket, the more you pay, and then they have to move their flights at various heights to avoid the other flights, and the air traffic controllers have to watch all this stuff. So if you start changing this, it's going to cause a cascade of problems. However, as big as those problems are, they're way, way smaller than the problems that Canada's having. I mean, Trump, in his deep understanding of science, said, we are going to penalize Canada because they're causing fires that are polluting our air. Well, good luck with that. But if Canada really wanted to solve its problem, I guarantee you it wouldn't be stymied by the airline saying, we're doing it this way and we don't want to change. Canada would say, yeah, you are going to change because I only need to change 1% of all the flights of the whole planet to save Canada, so I'm going to demand it. And there are many places in the world are similarly positioned to do this. It only takes one country to make a demand to make this happen. This is not a big change. Now, if you want to talk about a bigger change that Tor is talking about, where we might want to go down 5 degrees centigrade, yeah, then you may need to make a bigger change and get more people on board. But like anything, once we start doing something and we see whether it succeeds, it's going to be a lot easier to sell.
Yeah. Another
But I
thing I was
really,
wondering is if you could talk about um, something about the poles. There's this effect where, and let me see if I can pull it up. Uh,
yeah,
this
Brendan's been
one.
finding graphics to support this discussion.
No,
So
I've been creating them for the sake of. Let's see, where is it? Where is it? Where is it? Here it is. So supposedly there's the Brewer Dobson circulation, and it's
right,
basically you said something about the air's naturally going to move some of this to the poles.
right.
So it'll keep the H2SO4 right away from crops and forests, and and I guess it's going to create more acid rain or something like this. But if it's around the poles, do we have any idea of what that'll do to that environment if it sort of
Well,
culminates there?
the as I understand it, acid rain doesn't hurt animals. It only hurts plants and various types of fixtures like limestone buildings and things like that. So, since it's relatively devoid of plant life in the Antarctic and Arctic, it's not as much likely to affect those places. I'm not saying it wouldn't affect. It's stupid to say it doesn't affect. But we're not talking about whether X amount of SO2 is put in the environment. We're only talking about where it goes. So it's
Is
less
is the
harmful.
field going to create localized to wherever the trails are or something like that?
I'm sorry, would you say, Brendan?
Or is the shield that it's sort of creating going to just be localized to wherever the trails are?
You mean the contrails?
The contrails, yeah.
No, no, no. First of all, I said before, we don't want the contrails. The contrails are shields that are forcing energy moving in the wrong direction. Contrails keep heat in more than reflect heat out. So we don't want contrails. So that's another reason why we don't want
I,
planes in
I
the
should have
tropics.
just said where the planes travel is what I should
Yeah,
have said
where
there.
the planes travel changes whether the SO2 goes in the stratosphere or troposphere.
But is that different than where the shield, so to speak, is created?
I don't know what you mean by the word shields.
Yeah. So you mentioned the word shield when you're saying that we're going to let me pull up the document again. There's a sort of shield created when we release
Yeah, SO2 creates a shield against solar
well,
energy,
it,
right?
it forms aerosols of SO3, but eventually moves to the H2SO4, the sulfuric acid, basically. Um, but but yeah, so
That
when we're talking about a shield in the atmosphere that
okay, it reflects
blocks some
sunlight.
of the temperature coming through the sunlight or blocks the
Yeah, these particular minute amounts of sulfur dioxide get into the atmosphere and they quickly oxidize to H2SO3 and they cause aerosols, which means they mix with water and these particles become hundreds or thousands of times bigger than the seed that generated them. And this acts like a reflector, namely not a perfect reflector. When light hits a spherical surface, some of it is reflected directly, a lot of it is diffracted away, but as a consequence, a substantial amount never gets into the troposphere because it's pushed away by these little bubbles of aerosols. Okay, that's what we mean when we say
no.
SO2 causes an
So
air.
okay,
Yes,
so with that understanding, then to get to my question, it's if we're looking at quote unquote lowering the temperature,
yeah.
um, it doesn't seem like it's just 500 flights or something like that per year. It seems like it would have to be over if that were sort of, 500 flights or something like that per year. It seems like it would have to be over if that were sort of, 500 flights or something like that per year. It seems like it would have to be over if that were sort of, 500 flights or something like that per year. It seems like across all parts of the world, or is there any, or if one
Okay,
part
now you're asking
locally?
another question. You're
Yeah,
asking,
I guess I was wondering the effectiveness if, let's say, it's always from Houston to Atlanta, and
so
they
let's
go up,
talk.
it's like, okay, you
That
know.
kind of question is discussed by Reflective. We go back over here to the SI simulator. I have to put share back on so you can see my screen with
Oh,
the SI.
yeah, you have it, I believe. Yeah,
I'm still
yeah,
on.
you're
Okay.
showing.
All right. So if I'm
Well,
still,
it isn't sharing your screen. You have to press share to share your screen at the bottom.
I press the share button
Okay.
and
Did you select the window to share though?
it's coming in there now, I
Oh,
think.
okay. We're good.
Right. And hasn't come up yet. All right.
That's
All
okay.
right.
It'll
Now,
show.
now my screen is being shared, right?
There we go.
Okay.
Yeah, yeah, we see it now.
Now
Yeah.
I go to SI simulator. And over here, they talk about, actually, I did not study all of the things they studied, but they did talk about one of the problems of when they put Si2 in the atmosphere, where do they put it? Do they put it all at the equator or all at the 30th latitude, which is
Oh,
what you want?
yeah, yeah.
Or they put it all in the northern hemisphere. And what I've heard, and this is like to me, is just a rumor because I didn't see their article and where they published it. The assertion is if you put the SO2 all in the northern hemisphere, it's going to cause adverse effects on growing crops in the southern hemisphere. And they don't want to kill anybody because they're interested in cooling the whole planet, not just cooling one little area. So when
Mm.
I tell you the whole planet cools down, that's an average effect. In fact, there's a video I found, but I can't remember where it is right now, where they put they accidentally changed the SO2 concentration in the northern hemisphere, like North Atlantic, and it changed where it rained, and in northern Africa, plants were being they were making a crops in the just below the Sahara Desert. It's called the Sahel. And over there, the Sahel got less rain just because they put SO2 in the atmosphere in North Atlantic. So these are unintended side effects of this. But even though they know these kinds of things are going to happen, it's still dwarfed on the order of 100 to 1 to what's going to happen if we do nothing. And that's pretty much where it is. So to answer your question, Brendan,
Yep.
it's it's not intended. The reflective.org team is not planning on putting it all in one place and hoping it spreads out without a problem. They're expecting it will be a problem if they don't try to spread it out. So they're basically going to put half of the SO2 above the north of the equator and half south of the equator, and it'll spread out. But as to whether or not it's going to be even, no matter what they do, it won't be even. They know that that's part of the risk. And as Tor said earlier, we don't want to cool the planet too rapidly. That's going to cause all kinds of other problems. But anyway, so no, it isn't true that everything's going to go like you want it just because you hope. You've got to try to plan it. But what's obvious to me is it's going to be terrible to the planet if we lose all this ice in Antarctica and many of the glaciers in Europe and other parts of the world. That's going to cause sea level rise. And whether it's 2 meters or 5 meters or 100 meters, that's all potentially true. And once that happens, it could take many tens of thousands of years for the planet to readjust and regrow the ice in these places. So if we don't make a concerted effort now to save the ice, it won't come back. You won't get the ice back by going to what it was in 1900. You've got to do something more drastic. Okay. In fact, this might be a good segue for Tor to jump in. So why don't you take it
Well, if
away?
it's okay, I'll just make a couple more statements and then hand it off to Tor. Is that okay, Tor? Sure. A couple places where you might want to look as you're starting to go into this topic, Myron, is the National Acid Precipitation Assessment Program,
Uh,
NAPAP. They give reports to Congress that are publicly available, and they show lots of decades of data on how acid rain chemically dissolves calcium carbonate or limestone, and It talks about how the pH levels of acid rain are generally harmless to humans and animal skin contact and those sorts of things. So that'll probably strengthen some claims. But also, there's the National Academy of Sciences, or PNAS. Um, probably gonna have to look into the Brewer-Dobson circulations as a part of geophysics, because that's where, talking about the currents and the dispersion of this solution is going to come into play. Um, and then what else was there? There's Federal Aviation Administration in terms of different things that we'd need to look into about jet fuel, as well as altitude and travel and that sort of thing. But there's also different standard specifications for turbine fuels. The ASTM International does that. And then
I
the
just want
International Council on
we're
Clean
now
Transportation is on carbon specifically. So they're the
okay.
ones where we're getting this SO2 stat from. Probably where when you were searching with AI, it was pulling it from.
Okay, I want to stop you because we are really almost out of time.
Oh, sorry.
And
Yeah,
I,
yeah. Tor, go ahead. I just wanted to mention that there's still a lot to go, but I just wanted to point out some credible
this is not
sources.
ready for publication. We're really getting people to listen to it so we can improve it. But Tor wants to jump in. He's absolutely right.
Yeah.
We're only talking about cooling the atmosphere, and the planet has a lot more heat than what's in the atmosphere. Take it away, Tor.
Yeah, may I share the screen, my screen?
Oh, yeah.
Yes.
Sorry. Let me give you co-host. Sorry about that. Um, make co-host. There we go. You can share. Yeah. Sorry.
Okay, Tor, share the screen.
Default setting is known as just for security, probably.
Okay. So I'm going to start with the this government site called airnow.gov. I think they've added fire to it. But you can see the fires across Canada. Um, they're in Alaska, they're in Canada. Again, this is the air quality. These circles would say at a particular locality. But this moves around. See, I had this site. This, you can see the air quality, the dust in the air. I mean, this is a satellite map. So if you had a lot of sulfur in the grass, I don't think it's going to even come close to what people are inhaling in these fires. Um, fire smoke is probably 1,000 times more harmful than cigarette smoke, because it's full of sticky molecules that stick to your lungs. Um, it's really bad. I mean, literally running in a day when there's a lot of smoke, it's like smoking for a year.
I just want to point out, Tor lives in the state of Washington, and Debbie lives in San Diego. I may be wrong. You can correct me. And
Yeah.
I live in New Orleans. Brendan does, as well as Dr. Saeed. Go
Yes.
ahead.
Um, the third is I'm going to show you this drought map. The degree of drought right now across the West is the red is extreme,
Wow.
and this dark is where it is actually changing the landscape. And this has been playing out. This is dead on what you're getting. We're in a Cretaceous weather pattern that, as far as I understand my geologic training, where the interiors are kind of drying out. And this is not unique to North America. It's happening all over the world. I'll go to this one. This is the University of Maine Climate Reanalyzer. And if you just look at the 2 meter, we're in the heat wave right now in Washington
Yeah.
State. France is not. But if you look at the sea surface temperature anomaly, I like to say we get to Halloween every summer because look at Hudson Bay, that's coming in around 5 degrees Celsius warmer. The Mediterranean's about 5 degrees Celsius. And you see these blobs. This is caused by the dust and other stuff coming out of China that open up the sunlight. Whoops. And so if you look at the global thing, we have an El Nino, but it's like it's on steroids. So you're changing. You're not just warming the ocean. You're changing the circulation patterns of the ocean. And the thing about the ocean is that you're soaking up heat by sunlight going into the ocean. You essentially clear out the clouds of the ocean. So unless you change the CO2 in the atmosphere, it doesn't matter how cold you get. As long as that sunlight goes into the ocean, it won't change the dynamics of the ocean. Because if you change that dynamic underneath these ice shelves in Antarctica, I mean, you can't see it on the surface. Let me just click around to get to Antarctica. But the layer of cold water underneath Antarctica is thinning. And this heat, this warmth is getting down because the Antarctic bottom water underneath the ice is around 4 degrees Celsius. It's melting these ice shelves from the bottom up. So if you're going to change that dynamic, you need to freeze this whole area.
Yeah,
And if
Tor,
you want, I mean,
Tor,
if
let me just jump in, Tor. You suggested that if you want to save the ice in Antarctica, we need to cool the planet 6 degrees centigrade.
give or take 5 or 6, maybe more. I don't know much. You have to freeze the ocean, and the ocean's getting hot.
Right.
And unless you
So,
change the amount of sunlight that's going through into the ocean because of lack of cloud cover due to increased dust and CO2, you're not going to change it. Doesn't you see, energy gain is different than temperature. You can be in a really cold, windy place, but if you got clear sky, you get a lot of energy gain.
okay, well, I don't know how
Well,
far down
the
this.
second I want to point out this, these are the storms we get in the late winter of Antarctica. Last year I counted 13 of these. This one's been lasting for about a week, and it's putting just shy. If you look at the max temperatures, they're just shy of above freezing. This is on the Ross ice shelf, and we're coming in on an average. This is the average, not the high and the low. It is around 25 to 28 degrees Celsius over the ice shelf. So at a minimum, there we were getting a lot of precipitation. It's not right now, but this low pressure keeps moving around and putting massive amounts of snow. You understand, snow on an ice shelf insulates them. It's a bad thing. And if that melts in the summertime, the water goes down the cracks, it shatters the internal structure. Big ice does not melt, it crumbles. So we're very close to losing the Ross, the Ron, the Thwaites, and the Pylon in here, the Avery, and this whole structure down here and up here. So if you're going to slow that one down, that is like a freight train going 100 miles an hour. You're going to need something big. And so
Right.
that's why I say what you're talking as a solution to lower the temperature of the air, I see that's about maybe 10%.
Okay, but at least if we got that done, we would be on a train that could be speeded up. Okay,
Oh,
we could get
absolutely. Yeah.
we could get this done without polluting the planet any more than it's already being polluted, and show that this now it's possible. Because I've been trying to stop climate change through energy policy, energy efficiency, load flexibility, community solar, virtual peaking plants, all this stuff, which is good, but it isn't going to happen. It's not going to happen fast enough. We're going to need to stop the planet from cooling and reverse its cooling for a half a century or more, just to give time for those technologies to take over and dominate what's going on with the ice, internal combustion engines, and such things. So
Well,
what
the
we're
electrification is going to happen very quickly. The closure of the Strait of Hormuz in China is seeing to that.
I
But
know that point is we're
from
not going to stop reverse climate change unless we actively decide to do it.
Yeah, well,
When
again, energy gain of the oceans will only be stopped when we get the carbon levels down.
Mhm.
That is, I mean, that is
Right.
again, the sunlight, the energy going into the oceans is, I think, equivalent to three or three or four Hiroshima bombs going off every second.
Wow.
It's that much energy. I mean, it's changed the albedo of the Earth about 2%.
Okay, I'm trying to find a stopping point because we're past the 1 hour time that we're supposed to have the meeting. Although we did start 2 to 5 minutes late, so if we, we could go a little bit longer, Tor. But I want to try to
Well,
stay within our general time limits.
I agree, but I want to say that it would be better to say this is a piece of a larger strategy.
I agree.